The beauty of what we do with cold metal fusion is we are able to have a green part which is robust enough not only to handle but to manipulate. And by manipulate, I mean do surface milling, do targeted tolerancing. We talked about our accuracy, but and let's just say it's 0.1 millimeter. Well, a CNC machine accuracy is going to be 0.02 millimeter. That's just industry standard. So, you have the ability to take a part that's 0.1 millimeter accuracy, and then with a targeted approach, say these particular features in my part are critical dimensions. The other ones are not as critical, which is what the whole function of geometric tolerancing and dimensioning is all about for machining. Those same standards and typical approaches to manufacturing can be applied here. But I have the ability to target specific dimensions with a CNC to bring those tolerances to CNC accuracy, or 0.02 millimeters versus 0.1 millimeter, and do that in a intelligent way. The difference here is if I just CNC parts, every feature on my part is going to have that 0.1 or 0.02 millimeter accuracy, whether I want it or not. It's just a byproduct of CNC machining. So is that a good thing? Yeah, it is, but you're adding cost to the manufacturing that isn't necessary. And this is where cold metal fusion allows you to target where you use a CNC, when you use a CNC in a very specific way that saves money and time and gives you a part with better than CNC accuracy once it's centered. And you're able to really target where do I need CNC accuracy. And not only that, do it in a way where I don't have to have a very sophisticated setup, tooling, or machining strategy that you would normally have to have on very hard to cut materials like Inconel or titanium. So that's one thing.